Thank you so much. Thank you for everybody here. I'm deeply sorry for the delay, so I will try to apologize as making even more nice consideration during the presentation. So my name is Danilo. I'm technical evangelist. In my daily job, I work with companies of every size, from small startups, grown-up startups, large enterprises, public institutions, to help them in their journey through the cloud. And to start this journey, to see how Amazon itself came to what is now called Amazon Web Services, I would like you to go back in time, even more than 10 years ago, and to go back to 1994. So the screen here is not working, so I have to check the slides with you. So this is the first web page of Amazon, the retailer. How many people used a web browser in 1994 here? So you may remember it was a different web at the time. Tools like Mosaic were looking like the extreme frontier of technology. But still you can find here some of the key points that Amazon is still moving forward. For example, you can see that there is a mention of a tool called ICE that will help you find the content and suggest you what you may be interested to read. So we were still looking into those technologies that now you would call machine learning or predictive technologies as well. And actually, Amazon has still been quite a peculiar company. This is a letter that we sent to our shareholders in 1997. And we said to them, to the shareholders, that we are not interested in sacrificing long-term goals for short-term revenues. Everything for us is about the long term. And this is something that usually shareholders don't like to hear. But this is something that is really part of the DNA of our company. We want to have the time to test a lot of different things, and we want to measure and analyze, so have an analytical approach to understand what works and what not. So you need to measure and have data to bake every test that you do. And we also want to do big bets, bold bets. So we want to try new things. In 1994, Amazon was only selling books online. Now we are quite a different company. And a couple of those bold bets that we did can be, for example, Kindle, the ebook reader with all its ecosystem, and Amazon Web Services itself. Otherwise, I would not be here talking to you today. And of course, when you do big bets, not all of those will work. Some will work, some will fail, but in any case, you will learn something. So it's useful for a company to try new things, test new things, and extend beyond the reach of the current business. And to have this culture of innovation within a company, we really think there are two main parts that you have to implement. One is the mechanism to foster this innovation, and one is the company culture. And mechanism and culture are two things that are really complex and hard to change within a company. Starting from culture, we really like and love our leadership principles. Those principles that you see here are the principles that we use to hire people, and they are the same principles that are used to evaluate our job year after year. Of course, they are all important, but if I have to choose a few ones, the first one is the most important. It's customer obsession. Everything we do, and probably this is true for every business, but sometimes you forget to realize that everything you do is for your own customers. Anything else is a distraction. And if I have to pick a couple more, since those leadership principles apply to all tech figures inside, all employees in our company, I think big and invent and simplify. That means that every employee, from their unique perspective within the company, is still in charge of thinking outside the box, of finding new ways to simplify and invent things, how he is working for our company. And this is always nice to say with a clicker in your hands. We don't like slides. If we have to take a business decision, we like to write what we call narratives. So if there is a meeting when you have to take a decision, before of the meeting you send to everybody participating a short narrative, 1, 2, 3 pages, where you describe what you want to do, what are the advantages for your customers, and then in the meeting everybody will already have read this document, and you can start straight on with the constructive discussion. And when we want to create a new service or a new product, we like to start backwards from the customer. So the first thing that we do if we want to launch something is to write the press release for the launch. It will happen maybe in 2 years. But if you write the announcement immediately as the first thing you do before you implement the product, you will start to think how to describe what I want to do simply, because in a press release you can be complex, and how I can describe the real advantage for the customers, because in a press release you want to really help them understand why you are releasing this feature. And then you can start thinking about the questions, the frequently asked questions that you would get. And this is also useful because if you plan to launch something, try to think what will be the question that customer will ask me. It's probably where the complexity of this product is, because if people is asking questions, it means that it's not easy to use. And then you can start defining and writing the user manual. After this, you can start building the actual product or the actual service. But this part beforehand is really useful. But mechanism and culture are not always solving all problems. So in the year 2001, perfectly in time for the book and the movie, we found our own monolith within our IT department. So we found out that we were spending more time pushing a new feature in production than building the actual feature. And so we asked us, how can we change this? So we decided to change the way we were building applications from monolithic, as we would call them probably now, to smaller and smaller services, and to have these services complete as much as possible independently from each other. The idea is to create small teams. Each team is in charge of a specific small service, and the team is in charge of the whole life cycle of the service from development to test to going in production. So we call them the 2 pizza teams. That means that the whole team can be fed by 2 American pizza. Of course, it's bigger than the pizza you have here and the pizza that I'm used to in Italy. But that means usually the ideal size is 5, 7 people. Sometimes it can be big, slightly bigger. But if you have a small team completely in charge of choosing the right technology to build the product, developing the product, doing the test, doing the deployment in production, that means that they really feel as part of the building process. And if you ask to developers to do test and to do deployment, developers are lazy. This is probably a quality for developers. And they will automate the test and they will automate the deployment because they don't want to do that. So this is another nice effect of that. And the reason why this approach is better is has actually been described in the theory of systems. This is one of the pioneering authors in that area. And this is an empirical law that was described in John Gall's book from 1975 on the theory of systems. And it says something that we probably know, but it's really well formalized, that a complex system that works is always started as a simple system, and then you add features to that. You can never start from scratch designing and implementing a complex system. And this is something that you have to take in mind if you try to grow and add features to something. And so this is the overall story of the Amazon.com IT. So we started with this monolithic application for the retail side. We started to use smaller services in the year 2001 with these small teams. And then we went smaller and smaller into microservices and collection of microservices. And this is really the overview of the roadmap. And you can imagine if you have a small team of 5, 7 people that is creating a new service, do you want to spend time configuring a server, connecting the network cables, provisioning the storage, installing a database, tuning the database itself? The team is really focused on building and managing the service. So they start to ask internally to Amazon more powerful tools to automate those things. And from these internal tools, we started to think maybe we can create tools that are useful not only for our internal IT department, but for other people outside. And slightly more than 10 years ago, we launched our first public service that is as Amazon Web Services, that is Amazon S3, an object storage. And since then, this AWS, has grown, and we have now more than 1 million active customers that use our services within the last month. And for example, the first service that we launched, Amazon S3, this object storage normally peaks at millions of requests per second. So it's really grown a lot. And if you think we really start to look to a completely different kind of customer. So from the normal Amazon.com retail customer, we start to think these tools can be useful for companies, developers, makers, builders, people that want to create something new. And that's how AWS started. And we think that when you create a business, you really should think not how to create and be successful in this business, but how you can create and be successful with other people in this business. And that's why when you create something that enables other people to be creative, to build their ideas, that's really amazing. And that's why I think one of the reasons why AWS is so successful. And this is, as a consequence of that, we see now companies that in every industry, they start to create a new approach that sometimes disrupt the whole industry. Think of Airbnb. They are probably comparable, if not bigger than any hotel chain in the world. So they change the hospitality business. And this is probably one of the best definitions of digital transformation. It's from the chairman and CEO of General Electric. And he said that if you went to bed as a manufacturing industrial company, you wake up and now your company business is based around software and analytics. So software is really now the engine of the companies. And a couple of lessons that we learn and that really enable with cloud computing companies to move faster come from the lean manufacturing best practice. This is all started with Toyota in the 70s and has been adapted to startups by the Lean Startup book. One of the big lessons that you can adopt to yourself and you can think if you are doing it right is that you should eliminate all wait states within your company. Every time one of your resources is waiting for someone else to do something, like I'm waiting for the IP address to be released, I'm waiting for the network to be connected, I'm waiting for the database to be implemented, that's a waste of your resources. And extending the concept, you should eliminate all wastes. And waste for a company, as I said before, is everything that is not giving some benefit to your customer. So everything that is not giving a straight benefit to your customer should be really evaluated as, is this really important, or is it just something that I'm doing because maybe I got lost into this internal loop? And from 2006 to now, the AWS platform has grown. So now we have on top of our physical infrastructure, we have services that cover infrastructures, platforms, enterprise services, security. And we also have a vibrant marketplace where technology partners such as ISV can sell their whole complete solution on top of AWS. So for example, in computing, we have a broad range of different virtual machine types that you can use. We just recently launched the new P2 family that is based on heavily GPU optimized hardware so that you can use it for deep learning, for examples. We have a broader range of storage services from object storage to block storage using different technologies such as solid-state drives for a high throughput, for a high number of IOPS, or magnetic devices for a high throughput and very low cost. And we have a broad range of databases from relational databases, so we can manage relational databases with standard engines such as Oracle, SQL Server, MySQL, Postgres, to NoSQL databases, and tools like multi-AZ replication. So that feature, I love it because in the past I've worked on projects to replicate a database synchronously across 2 different data centers. Usually it was 6 months of work and it was never easy. Now you have a flag and you can enable this synchronous replication across different data centers as a feature of your database. It's just a flag that you enable. Of course it has a cost, but it's very easy to use. And also we have features on the security and compliance, because we are seeing people putting more and more important and relevant data on AWS. And we want really our customer to be in charge of the security and the life cycle of data, because it's their own data. We don't look at it, we can't look at it for the process that we have in place. So security and compliance and access control is really full of features that you can use. And those are a few customers that I like to mention. One is Philips, that is using AWS in a healthcare project. So they move 15 petabytes of patient data, that is healthcare data, very critical data, on AWS. And they use it to analyze and improve the life of patients that can, for example, live in their home and be monitored by their caregiver without living in an hospital or in a specific facility. We have Bristol Myers Squibb. They run clinical trials, simulation of tests that they do on medical compounds, and they run faster, 98% faster on AWS than on on-premise infrastructure. And also more lighter workloads, such as games. Supercell it's here in the Nordics, here in Europe. They use us for their gaming platform. They have millions of players. And gaming is an interesting technology, because we talk a lot about scalability in IT when you have a lot of users. Gaming is interesting because usually a successful game has the highest number of players on the first day the game is out. So you create the expectation, you launch the game, and the first time you open the public access to the game, you have the highest peak of players, and then you will slowly go down, and maybe if you release a new feature in your game, you have another small peak. But it's really scalability in the opposite direction. The first day is the hardest. And during a panel discussion, I think it was really nice that the CEO of Infor was talking with one of his peers, and he said really that for a company, it's not important to focus on managing the infrastructure. It's really important to focus on customers, as we were saying for the waste. So friends, don't let friends build data centers. It's something that it's so complex to do, and it's better to leave it to who is very quick to do that. So, going on with time, we release a lot of features, a lot of services. I'd like to give you a couple of hints on where we are going and where we think cloud computing is helping its customer more. The first concept is around how to build new applications. So try to use cloud computing as services, not as servers. This is really the right point of view. And usually we are used to a virtual machine that we can manage with Amazon EC2, for example. We have tools to manage containers at scale, Docker containers. And we recently launched a service, 1.5 years ago, that is AWS Lambda. Is a service where you can put your code grouped in functions, and we will execute the functions for you. So in the world of virtual machines, you have image of your virtual machines, and those images you use it for hours or months, and then you can dispose of them because you only pay for what you use. You are still in charge of patching everything, the operating system, everything that is on top of the virtual machine is in charge of the customer. You usually have a lot of different tasks and applications inside a single virtual machine, and you pay for the VM and for the hours that you use them. With containers, everything is smaller and quicker. With containers, you have smaller container files. You use containers usually for minutes or days. Versioning is part of the container themselves, for example, with Docker. And you usually focus each container on a single task, and then you compose multiple containers together to create an application. And you still pay for the virtual machines, because containers must run in some virtual machine that you must provision. With Lambda functions, everything is even smaller and more granular. So you give us the code, and we will execute the code for you. You can use those functions for microseconds or up to seconds. We still manage versioning for you, and usually these functions are much smaller even than a container. You use them for a single task, and you only pay for the memory you use and the execution time, and you pay for the hundreds of milliseconds of execution time. So it's very, very granular, and we give also a huge free tier. So every AWS account, a new account or old account, can have up up to 3.2 million of seconds of free execution time every month. I say up to because it depends on how much memory you use. If you use more memory, you can have less execution time, but it's still a lot of time and computing time that you have. And we've seen, for example, startups or companies doing prototypes starting with this approach. They can build an application with no cost and then eventually go in production. Even with the tens of thousands of users, you can have no cost with AWS Lambda because of this huge free tier. And this is the new frontier that we see is coming, is the idea of serverless computing. Usually I don't like to define something as the absence of something else, so serverless. But the idea is really to create new services where you don't need to think about the underlying infrastructure. That's something that the service provider takes care. You only need to focus on the feature that you want to build. And AWS Lambda is a good example of it. No server is better than to manage than no servers. And actually, if we look back to 10 years ago, the first service that we launched, Amazon S3, the object storage, was really in that direction. Because with S3, you can put content, you can delete, use, read content, you can encrypt, you can add. And we do everything for you. You don't need to pre-provision storage. You only pay for the data that you put inside this storage. So it's really very fast to use. And we will continuously reduce the latency for you, so you don't need to tune the storage. And we continuously reduce cost as much as we grow. We optimize our own internal infrastructure, and we will reduce the cost for our customers. And on top of AWS Lambda, just to give you an idea of how you can use it, and there's customers like Coca-Cola that is using something similar, you can use the Amazon API Gateway so that you design your web API, and then you link the logic of your APIs to Lambda functions so that they are published as web API usable from a web application or a mobile app. And this is the setup that they used for this interesting application. So I'm not talking about a really enterprisey workload here, but you may remember the latest European Football Championship a few months ago. So the anthem was written from David Guetta, and it was played just before the final. And actually, the idea behind this anthem was that everybody could sing together with David Guetta. And they prepared a website and an app where everybody could record their voice, and they had up to 1 million people recording their voice, and this voice was mixed together with the voice of Guetta in the final edit of the song. Everything was built using AWS Lambda and the API Gateway and S3 for the storage, and it was really super cheap considering that they had 1 million people using this service for recording the video and singing with David Guetta. And the other hint that I want to give you is look around for new technologies. We are seeing really new things are coming, and the best way to put it is probably to say that the future is here. And why I'm saying that the future is here? I'm saying that because if you look around and you look at what great visionaries of the past saw as the future, it's really something that we are experiencing now. So this is Nikola Tesla. He's one of the greatest geniuses of the last century. He was a pioneer of wireless technologies, and he said something that now makes a lot of sense. He said, when wireless is perfectly applied, the whole earth will be converted into a huge brain. And we're starting to see something like that. The internet is starting to take this shape. And now we are going into even a deeper stage with the Internet of Things. If we think how we as people work, how our brain works, we have sensors, our hands, the eyes, the taste, and our sensors are sending information to our brain. We process this information, and then we perform actions based on those sensations. The Internet of Things is replicating the same approach across a different scale, because we can deploy sensors everywhere. So there are sensors on buses to measure the air quality. You can put sensors in an agricultural field to measure the humidity of the ground. And those sensors send the information to a new kind of brain that can run in the cloud and can be as much smart as you want. And then you can take decision and use actuators to change the state of the world. So if the air quality is too high, you can close a street. If the humidity is too low, you can open an irrigation system in a field. And we are seeing amazing things done with this kind of approach. One that I really like is from Sonos. So Sonos they produce smart musical device that you can use wirelessly inside your home. And one thing that it really hit me when I read it is that they use the same physical device for 10 years. So we are used that every year our smartphone is old. Every 2 years our car is starting to get old compared to the car of your neighbor. So they use the same physical device for 10 years, and they were still perceived as the leader in the technology of wireless music. And that's why they could add new features doing software upgrade, firmware upgrade in the device. At the end of this 10-year life cycle of the product, they were adding features that simply didn't exist when they invented and designed this product. For example, 12, 13 years ago, listening to music in streaming was something that nobody would think about doing. You would not think that someone could walk in the street and listen to music in streaming. Now services such as Spotify are very common. And they could add this feature to their device, and at the end of the life cycle of the device, most of their customers were actually using this feature and not listening to MP3s that were probably much more popular some time ago. And also Amazon is very active in the IoT area. We have a lot of devices. One that I would like to stress is the Amazon Echo, part of the Amazon Alexa services. It's a device where you can talk normally with your voice. Currently we support English. We just recently launched to the UK and Germany, so we are going to support German language very soon. And the idea is that you can talk with this device, add skills, and integrate with the whole broad range of internet services that are around. You can call a Uber car with this, you can order your pizza with this, and it's really natural. I think that in the future, natural interfaces will be more and more common. Probably the smartphone is starting to reach its limit in the capability that you can add, and natural interfaces will help extend the reach of new technologies to younger people and older people that today are a little bit cut out from the use of new technologies. And we have this AWS IoT platform that helps you develop very quickly application for the IoT. So you can very easily and securely connect your devices using different protocols from web services, WebSockets, MQTT to AWS. Then we have a rule engine where you can process this huge quantity of data very quickly, filter the data you need, and then act as a bridge with other AWS services. And we also have the concept of device shadow. So since with the IoT you start to distribute your devices across all the world, you may lose connectivity. It's very difficult that you can guarantee connectivity for all your devices spread across the world. So the idea is to create a shadow of your device that we manage, a virtual device where the latest state is always kept, and the application that you write must not manage the state of the device. You can directly talk with the shadow, and when the device is connected, we will synchronize the shadow with the device. If the device is disconnected, the application will transparently continue to find the latest reported state and change the state of the device on the shadow so that you don't need to manage that and you simplify your application development. So if you want to move workloads to AWS, you will not be the first one. So we have 10 years of experience now as AWS and the partners that we have on the field that are helping customers in the migration. So this is a well-trodden path. So we have a lot of best practice that we can help you with. And those are the 4 pillars of a correct migration. So you should know the technology, so training and certification helps at the beginning especially. You should think how you want to migrate your data, and databases as well. Databases are more critical than normal data because databases are live data that is continuously updated, and how to migrate your application. So just to give you an idea, we have a broad range of features to cover this. From integrated networking so that you can seamlessly use our infrastructure as an extension of your data center, federation of your identities so that all your permissions can be used on AWS very easily, and on. And this is the reason why we are the destination of a lot of companies that decided to go all in on AWS. So really, we have a few of those. You can have the video online where they sold their data center space at the end of the migration. And customers, usually they have a phased approach. This is Capital One, a bank in the US. They started with experimentation. And this is good because you can experiment on AWS very cheaply. Then they move to dev and test, and this is a very critical point, because usually people, they try to save money on dev and test, thinking that production is very critical. But actually, the first requirement that I get from all customers is the speed. They want to move quicker, to have a shorter time to market, to be more agile. And even if production is important, the speed of your company, the agility of your company lives in the dev and test environment. So don't think that you can only squeeze money out of it. Think how you can improve it. And then they move to production, of course. For data, of course, we have different patterns. You can have smaller granular data, bigger chunks of data to migrate to the cloud. And we have different services that can help you with that. For example, Kinesis is a platform from streaming data. So if you have very granular data that you need to stream to another for processing, this is often used together with the IoT platform. We have a platform to do that. And then on the other extreme, if you have huge quantity of data, you can order from the AWS console this device. It's called Snowball. We will ship it to you. You can connect it. It currently has 80 terabytes of disk space and 10 gigabytes of speed. And you can connect it to your network, store your data, send it to us. The screen that you see on the device is actually a e-ink screen, the same that you find in a Kindle, and it automatically contains the label for tracking and shipping the device back. And everything is encrypted end-to-end, so that only when the data is written back on AWS is decrypted. And if you need more, you can connect more of them in parallel. And we see customers that are starting to use this approach. You don't need to fulfill all the terabytes, of course. For database migration, that is very critical, we have a tool that allows you to migrate database live. So you don't need to close your on-premise database, but you can start migrating them to AWS and then evaluate if you like what we do for you. And we have also a schema conversion tool. This is because lots of customers showed the interest to move from commercial database to open databases such as MySQL or Postgres. And this tool is a free tool that you can download and use on premises. Will tell you how much, will automatically do some migration for you of the database, and will also tell you how you can do the changes that cannot be done automatically. And this supports also data warehouse workloads, so moving from data warehouse specific systems such as Oracle Exadata or Teradata to Amazon Redshift, our online data warehouse service. And this is an example of a customer in Japan. It's a gaming customer. They moved simply from MySQL on AWS to Amazon Aurora. Amazon Aurora is our own implementation of a relational database. It's 100% compatible with MySQL, but it's designed to run on the cloud, so it's taking advantage of every feature that is available in the cloud. So by just switching the database on the same hardware, they reduce the latency of their gaming platform to 1/3 the original latency, from 15 milliseconds to 5 milliseconds. So it's a lot of things that I wanted to tell you. I hope it was interesting. The key remarks are really think about the cloud as services, not as servers. Think of the new technologies that are opening new and broad possibility, especially the Internet of Things. And if you want to use a cloud provider, we have really the history to help you do that and share those practices with you through our partners. The most important feature of cloud is really that you can test things without an initial investment. So that if you want to innovate, you need to run experiments, and you need to accept that some, if not most of your experiments will fail. So the best way to innovate is really to reduce the cost of experimenting, and AWS is really helping you do that. Thank you.